My name is Kamal Bakshi, and I'm going to answer today a multi-billion-dollar question. Can you maintain your fiber channel, or can you move to TCP, or do you have to maintain both? So, give you a quick example. Let me just turn it on. All right, a little bit about myself. For the past 20 years, actually 40 years now, I've been working with customers, help them adopt new technologies, whether it is voice over IP when Cisco launched it, whether it's the campus switching, IBM, mainframe protocols, channel protocols, APPN, LU62, token ring, and now storage, and of course the SDN networking and all that. So I help customers adopt new technologies, and I've worked at different companies in the past also, Bell Labs, Apple Computers, and so on, 3Com. In my experience, I come up with my mantra of technology adoption is the 5 key things. A new technology, if it comes out, like we're going to talk about NVMe, OF, right? So first is awareness. People have to know, customers have to know what is this technology about, right? So it's all the marketing and everything. Second is the customers have to know what is the value proposition of this technology, what it brings to them. It has to match what they have in their network or what their expectations are. You cannot just provide a technology which customer doesn't need. There's no place for it in their network, right? So you cannot be forcing that. So it has to match their requirements. Third is the attitude. It's a very big one. At last 40 years, I've gone through so many RFPs, where one customer will buy our product, the next one will drop it, they will not. And I'm like, what happened? Technology is there, advantages, I show you demos. It is the psychology, the human psychology. The attitude, when you look at the iPhone, if you like it at the first time, your attitude will be positive, you'll buy it. Some people will buy the Mac, some people will buy the Windows, right? So it's an initial. So it's very personal, based on your own experience, based on your own background, you will form an attitude immediately about a technology. And make sure when you come up with a new technology, make sure the people have a positive attitude, because once they form a negative attitude, it's very hard to break that back and go into a positive attitude. And then starts the adoption phase. That's the biggest phase in new technology. If the customer don't adopt, technology is just going to stay at the shelf. When I worked at the Bell Labs, they have thousands and thousands of inventions just stayed at the shelves because customer didn't adopt it, right? So adoption is very key. It has to be non-disruptive. It has to be easy to adopt it in there. And the last is, once they adopt it, they should really like it, If I buy iPhone and if I don't like it, I'm not going to buy it next generation, So the advantage has to be there. The ROI has to be there. It has to be easy to maintain. I don't want to be calling, people somewhere else to every time there's a problem in the network, right? So those are the 5 mantras when you deploy NVMe technology or any technology. Just put those into your list and go through that and you will not fail. And my humble request is anything which I'm presenting here, and this session is very timely placed, thank you, Sneha. Anything what these guys have written in spec, as a customer working with about half a dozen of customers who are actually trying to deploy NVMe TCP CDC, Cisco is the second largest fiber channel transport provider, and we're the largest enterprise Ethernet data center transport provider with switches and all that. So I get a pretty good vision of both sides of it, from fiber channel to Ethernet, and I'm working with a handful of large financial customers. Their bosses, their CTOs have told them to look into NVMe TCP, can it save you money? So anything what I'm presenting here is the testing which is going on at Cisco Proof of Concept Lab. And please download the spec, because that's what I did also, and for the last 2 years I've been working on this. And don't take NVMe lightly. People say it's just an NVMe, big deal, but look at the numbers. My goodness, $175 billion? By 2030? That's all talking about the flash NVMe, right? That's within the server or something, but once it comes out on the transport, that's where NVMe OF come into place, multiple options there, right? And very cleverly, hats off to these guys in NVMe standards body, They said they're going to be transport agnostic. They said, okay, we're going to have the NVMe command. Well, work on any transport you want to do it. They just encapsulated it, call it command capsule. Amazing idea, right? So it's not like iSCSI or FCOE or FCIP. It's just NVMe command. You put it on fiber channel, it's still an NVMe command. You put it on the Rocky, it's still an NVMe command. Put it on the TCP, it's still an NVMe command inside it. So that's a very good architecture. So I think everybody, there is NVMe already deployed even in your phones, servers and everything. And once we get out of the box, you will require some kind of an NVMe transport. So we might as well all start to learn about it. By the way, I have a different way of a presentation here. I'm going to give you a lot of animation and I'm going to give you a lot of information here. So don't try to read the slides. There are over 300 slides. I'm not going to go through all of them. So please download the slides from the SNIA website. They're having a trouble because they never had that large presentation uploaded. So in a couple of days, it should be there. So right now, the presentation up there is 290 slides, but mine has 333 slides. So make sure you get that, all of that. So what is NVMe OF or what is NVMe fiber channel? Why do I care about it? What you should watch out for? I started to ask that question. I've been with storage since 2002, since we started MDS fiber channel switching. With NVMe now two years now working on it with fiber channel and TCP. I went through thousands of pages of spec. Hats off, and thank you very much for NVMe for ratifying it and making it NVMe 2.0 separate spec, because now I can open all 6 of them and I can say, okay, go here, now go to section this, section that. It makes it much easier, you know. Before it was one big spec, very difficult. So we have a lab. Anything which I'm presenting you here is, and I'm going to move closer to this. Anything that I'm presenting you here is actual implementation, actual traces. Hopefully, Rachel, there's no feedback in there. Let me know if there's a feedback. And we have a lab. We bring in the customers. We call it a proof of concept lab. I have about 6 racks over there full of NVMe gear, tracers, analyzers. And then I have a whole bunch of team working, you know, and we worked with some of the startup companies like, you know, Pavilion, Marvell came into the picture. I'm testing with Dell, Lightweights, you know, Sagi came along and I asked him a lot of NVMe TCP questions. So very practical approach. What I'm trying to do here, what Cisco is trying to do here, we got the technology and we are protocol agnostic. That means we'll work with any protocol. So if you have NVMe fiber channel, our product supports that. We'll take you all the way to 128 gig fiber channel. Standard is going to come out end of the year, right? I was just talking to Craig. If you want to do NVMe TCP, we'll support you there. If you want to do NVMe Rocky, we'll support you there. Any other protocol you let us know, we'll do that, right? So in this talk, I'm going to talk about simply 3 topics, and the rest of the other topics, I put it out there. And I have a presentation I recently last month talked at Cisco Live, and those talks are available, those slides and those videos are available there, so you can check out over there. So 3 topics I'm going to talk about is the data center storage architecture, how they look like. I put a timer in my hand. I think it's not going to work out, so I'm going to put my phone in the pocket. So Ethernet is happening. Ethernet speeds are going in there, 200 gig, 100 gig, 400 gig. And by industry, if you Google it out, you will find that everybody is poised to do 800 gig once that comes out. It is massively, all guys are deploying Ethernet at a very large scale. It is given in there, it is happening, right? So, and the fiber channel has been there since 1994, right? I mean, that's, you know, even before that, fiber channel when the spec came out, it is the gold standard for block storage. Don't go by anything else. It is the gold standard, and it's ever been since there. I call it a King Kong, still standing there, regardless how many other technologies came, it's still standing there. And world's largest banks, world's largest financial institutions, all their applications reliably run on fiber channel. Oh heck, the mainframe runs on fiber channel storage also, you know, the FICON, right? SCON, when they were migrated to fiber, they choose the fiber channel protocol. Fiber channel protocol, and I was having conversation with Craig again yesterday, one of the guys the spec wrote. It was designed to take any transport. It was a transport protocol agnostic of any payload on top of it. So they mapped SCSI on it very nicely. Then they mapped mainframe, SB, single byte command sets on it very nicely. Well, guess what? NVMe nicely maps into fiber channel protocol also. So hats off to the guys who developed this fiber channel mappings and all those things. Very good protocol, very robust protocols, going on very nicely. NVMe came along seamlessly. No changes required on the network. It's a fiber channel protocol. Just you needed drivers on the both sides, target and thing. It works out great. So is fiber channel meeting your need today? I'm from a camp that if somebody gives me a new technology, whatever it is, and if I don't have a problem, why do I need a new technology? What am I trying to solve? So is fiber channel, is a checklist right now in your mind, and I have 7 points in here, and the 8th I will show you in a second. Is fiber channel providing you security? Yes, this is a fiber channel security protocol, hardware zoning. Is fiber channel high available? Yes, Fabric A and B, multipathing, lossless behavior, buffer-to-buffer credits. Is fiber channel has a built-in automation? SDN in IP networking started recently. Fiber channel has been doing automations long time before that, right? FCIDs automatically, gets you assigned in there. The directory, the name servers, distributed name servers on every switch, right? No foreign host can come in. At the ingress switch, they will just reject it, port zoning, right? It is the high performance, congestion control. For the last 20 years, we're trying to figure it out how to fix fiber channel congestion problems. There's a speed mismatch. Every time, if a 100 gig or like in fiber channel, if a 16 gig host is going to 8 gig target, it's going to create a backlog pressure all the way back. And it's a lossless behavior. You cannot drop a packet. That means in the buffer, in the switch, you will have to hold the packet. That means congestion will go all the way back. So that's called slow drain devices, right? So there is technologies out there now, like with FPIN standardizing. Cisco has a dynamic ingress rate limiting, Talking about the management, oh my goodness. Fiber channel, even including the NVMe analytics, it is there. Ethernet world, you send a packet, you just count that, that's about it. Maybe you look inside the packet, VXLAN, header, VLAN. In fiber channel, we have to worry about the return also. Because if it's a write going on, it is the write acknowledgement came back status. So we have to hold the packet or some kind of a metadata, so we have bidirectional analytics in there. So very advanced analytics in the fiber channel going on. Scalability, yes, we know how much fiber channel can scale. There's a virtual SANs and all that. And the biggest thing is the 0.7 out of all these things. It's an ecosystem. Fiber channel is deployed with everybody certifying it for you. With Dell certifying it, HPE is certifying their own, Pure certifying their own, Cisco certifying, with all these new technologies comes up. So everybody plays together. It took a number of years to get to that point. So it all works fine. So we don't have any problem, Houston. You're ready to take off with fiber channel. NVMe very cleverly fits with fiber channel. It gives more life to fiber channel. Okay, life is going pretty good. Move forward to 2020. NVMe guys released NVMe TCP spec. Okay, what is it? Now customers look at it. They start calling Cisco. They're saying, hey, this is NVMe storage can go on TCP. Can we do? What can we do about it? It also seamlessly fit with TCP existing architecture. You don't need a special TCP to do that. Even in fact, TCP networks don't even know there's an NVMe going on the payload. Just like fiber channel, FCP doesn't know. I mean, it knows, but it seamlessly matches into the transport. Same thing with TCP, just different protocol numbers. There's a headers I'll show you and all that. Okay, so question is, customers starting to think again, can TCP provides them better price performance? I mean, they're happy with fiber channel, right? I mean, all services working great for a number of years, but in the back of the mind, it's always price and can they get better performance? So they asked that question again. I put them the same answer. I said, check your 7 things. Is TCP can provide you that security? Can TCP provide all those 7 things? I don't have to go through that, right? You will have the slides in there. Okay, so I try to answer that for my customers. There is an 8th one, very important one. I was just chatting with one of the analysts over here. Cloud. Is the cloud storage. People are moving towards the cloud storage, and you want to watch what cloud guys are doing here, right? Microsoft was here yesterday, they have their direct drive and all those things, and they're not using NVMe, they're using their own kind of a protocol at the back end. They also use Rocky, in certain format. Google uses some format of some. So they're using all their own protocols, but there's all something based on TCP or UDP kind of a packets in the back end, right? So that's also very important fact. As people move to the cloud, what storage protocol will be there? So you can connect your on-premises to the cloud, hybrid, and back and forth. Right? And I'm not saying it's your choice, right? I mean, Fiber Channel will have a hard time going to the cloud, right? From the on-premises all the way out there. But then again, Fiber Channel applications requiring low latencies and all that, maybe on-premises, that makes sense. Maybe certain other workloads. So you need to start to separate out your workloads. All workloads not are the same things. So keep certain applications, SAP HANA running on your Fiber Channel on-premises. You want to run some analytics. Some Walmart wants to run some how many iPhones they sold. They can run that in the cloud, get whatever the cloud storage they want to do and all that, right? So my answer to these, can NVMe do is security, yes, there's a dedicated fabric. Yes, so I moved out of my spot, so I need to come back. So in security, yes, TLS 1.3. Claudio is sitting here, he wrote all the spec about it. Hardware zoning have to be done by software-defined networking. It'll be vendor-based. How does Cisco do it? How does other vendors do it? And their high availability, you can build multiple fabrics with Ethernet. Multipathing works, ANA works in the NVMe TCP also. Lossless, we have PFCs. How about automation? Well, addressing, again, if we do the addressing like Fiber Channel does FCIDs automatically, in IP world, we'll have to do SDN-based. So somebody will have to come out like, whether it's Cisco ACI or anybody else, they will have to come out how to provide IP addressing. How about the directory service name change and all those things in Fiber Channel automation? So this is where NVMe guys are building a couple of specs in there. With the CDC is part of that, TP 8009, 8010, and there are more follow-on specs. I'll go into that. Congestion control. TCP has been working with congestion control for God knows for how many years at the internet level. But it is yet to be seen, can the storage traffic on NVMe TCP can the TCP current congestion control methods can manage that, like fast retransmits, congestion window sizes and control and all that in there. Management is the big one. You can manage an NVMe TCP frames going in, you can say how many packets went and all that, but when you have to look inside NVMe TCP packet, and I try to look at that, and our Cisco IP switches can look deep inside the packet, no problem. But NVMe TCP spec says you can segment the packet. And once you segment the packet, the segmented packets don't have NVMe headers on it. So the switch will have to maintain all the segmented packets inside the switch to make any sense out of if a read is going out or where is that command. So it becomes very big memory consumption at the switch. So it has to be done at the endpoint. So Cisco is now working with other endpoint vendors, SmartNIC adapters to give us some endpoints analytics information on NVMe TCP because it's much easier. In Fiber Channel switching, we can track all that in the switch because we have a dedicated ASICs within the Fiber Channel Cisco switches. We track bidirectional things in there. Let me rush here because I have little time left. So there is a scalability. TCP is highly scalable, man. I mean, you can build. Customers are asking us to build like a global sizes NVMe TCP networks, right? They're saying, I have a data center here. Somebody was talking about the edge computing. Edge guys require certain application, NVMe TCP, send the data right to the edge. Edge guys take it to the cloud. TCP can go to the cloud and they come back. It's a highly portable protocol. You don't drop any packets or anything, right? TCP. Even if you drop, retransmits, right? Okay. So the question is, if I have a data center, I have a Fiber Channel, can I still use certain workloads on the TCP Ethernet while I maintain my Fiber Channel and while the TCP continues to provide me with new enhancements to match Fiber Channel features like services and all that? So let's look at that. I'm going to look deeper inside the storage array, how it looks like. We talked about a lot of discovery controller, direct discovery controller. I'm going to take you inside a storage array. Inside. Literally, we're going to go inside. And this could be anything. It could be Fiber Channel, Ethernet, or anything. There's an adapter, there's a CPU, there's a PCI bus. There's your NVMe SSD inserted into that, right? There's multiple of them, 20 of them, and one RU, whatever you have. It's a PCI bus, it's a memory map, so there's a memory config registers over there. Within the SSD, there's a controller, NVMe. Now, this is the beauty. I don't know if you noticed this thing. NVMe does not have a controller in the sense it does not have an adapter controller. Just like a SATA has it, SAS has it, NVMe doesn't have an adapter. So all the functions of NVMe, SCSI had like thousands of commands. So you needed an adapter. You cannot just put all that onto the SCSI storage itself. You need an external adapter. And that adapter become a bottleneck. That's why SAS and SATA cannot go faster, because everything has to go to this adapter. In NVMe directly mapped into PCIe, the command set is less than a dozen mandatory. You can just implement the NVMe on it, and hence the controller function of the all NVMe went on top of the NVMe SSD itself. And the way the NVMe architecture is designed with the namespaces and the discovery controller, IO controller, it can all map together and figure it out where everything is, right? And you can go all the way. So IO controller, there's one type of a controller that has the flash, that has the namespace, that has the namespace ID, still uses the logical block address, what we use in the SCSI, same as the NVMe, though there's a spec out there, key value. Now, another thing is the discovery controller. How do you know where the IO controller is, who has the namespace? There could be dozens of these IO controllers now because each SSD is in there, right? Or there could be, So discovery controller will know every IO controller. Discovery controller does not have any IOs attached to it, any flash attached to it. It's only, its whole role is to tell you about where the IO controllers are, all right? And the next thing is, there's also an administrative controller, right, with the MI. There's a whole spec on the NVMe. And then for NVMe TCP, NVMe consortium has to build an external controller, CDC, they call it centralized discovery controller, because when you plug your storage in NVMe network and you plug your host into NVMe TCP network, nothing happens. Because it's a TCP network, it's not going to do anything, right? It's not fiber channel, it's going to quickly start to figure out name servers, this and that. So there has to be some kind of you have to tell the host, TCP host, to go somewhere to find your storage is. Where should it go? There could be thousands of these storage endpoints. So NVMe, guys said, okay, we'll create a centralized discovery controller, a VM running on the network. The host will automatically go there. The CDC, that centralized discovery controller, now we're going to call this discovery controller as a direct discovery controller because you're directly on the storage itself, right? So you see the nomenclature here a little bit in there. Then NVMe put a lot of features, all the logs, everything you want to know about NVMe, they put it in different places in there. Properties are right at the NVMe controller memory. What is this NVMe about? It's all property, it's controller properties, configuration things and all that. Then there are 3 buffers, in memory buffers. You can go to log. NVMe logs everything. And you can actually issue an NVMe CLI command and get all this log information out and everything in there. You can build an API, get all this feature out. There's NVMe tunable features. You can set how many queues you want, what's the depth of the queues and so forth in there. And why I'm talking about it, let me show it to you, right? There's different types of things, all sorts of identify log pages. Again, you have the slide deck, so don't try to read all of this thing. But you're getting a picture inside the architecture I've taken you. There is a IO controller, that's where the flash is attached. There's a discovery controller that will tell you which IO controllers are part of it. There could be dozens of IO controllers. This discovery controller will tell you about it. There's NVMe port that will tell you behind me, once you access me over the transport, what kind of a discovery controller is or what kind of a subsystems are behind me, And then, of course, in the memory, we create all sorts of these control registers, queues, and all these architectures and everything. All right. So let's go look inside the fiber channel. And we know fiber channel here very well. So I will not go into too much detail, and I will just let it run. The host comes up, there's the fiber channel drivers. This is I'm talking about the storage. Now, mind it, NVMe is a PCI protocol. NVMe has a PCI at the back end, is attached to it, it has to speak PCIe. Of course, there's Ethernet also, now. But PCI is main thing. But when it comes out of the box, it cannot speak PCI anymore. It has to speak some transport, and that's what NVMe over Fabric is. And those are some of the protocol architectures. I'll just talk about fiber channel quickly in there. All right, so everybody knows I have 4 steps here. You have to connect to the NVMe storage. You have to create a queue. It's a queuing architecture. NVMe works between the queues, at the host and at the controller itself. The host creates at the controller the queues, NVMe. In fact, it creates admin queues first so that you can send all the commands. And it's creating those. There's a create IO connection. This is specifically designed for the fiber channel in there, and I'll go into that detail. After it creates the admin queue, it creates the IO queues. IO queues only carries read-write commands. It doesn't carry any admin commands in there. And once it connects to that IO queues, then NVMe host can issue commands, and it can find where the discovery controller is on that device, on the target, and it can ask him, tell me what are the namespaces or what kind of I/O controller you have, and then it can go talk to the I/O controller and get the namespaces in there. So this whole concept of NVMe subsystem is there with the controller, controller ID, namespaces, NVMe ports, NVMe queues. So here's an idea. Here's an example. A host in Fibre Channel sends, he wants to write. It's going to go into memory. He's going to say, okay, what information you want me to write? There's some data series in there. He's going to call in the NVMe Fibre Channel driver. He's going to say, hey, I need to talk. He's going to say, where is the target? I need to create an NVMe association. I just cannot talk to him. I need to create those queues. So it's going to go ahead and create an NVMe associations with the target. Now it's going to go create the queues. It's going to say admin queue first, and then it's going to create all the I/O queues, and every queue is identified by the connection ID within the Fibre Channel frames, and you can see that. And it has to know which queue you're sending packets to, read writes. You could have up to 65,000 I/O queues. Admin queue is always number 0, and everything else starts with number 1, I/O queues. And then once the packet reaches the port, NVMe, it's a Fibre Channel transport. So at Fibre Channel, everything is done in sequences and exchange IDs. So it's going to map that flow into a particular exchange ID, and it's going to get it on the other side. So see how cleverly Fibre Channel protocol doesn't even know NVMe is going on top of it. It's just an exchange standard in there. Of course, it knows there's a protocol in there which will tell you that. On the host perspective, it does the write. It will go to the adapter. It will say, okay, I'm going to send a frame out in there. It goes to the storage. There will be some MSI interrupts in there. It will actually put the info packet into the I/O queue, and actually it's going to ring the doorbell, and it's going to tell the controller to fetch the write commands, and it's going to start writing it on there. So this is how it works in the reverse path and all this thing. Now you understand how this NVMe subsystem is. Now let's look at it. What are the different pieces in there? So that port will tell you, will be identified in the initial Fibre Channel commands. And there's some new commands in there like link services, connect association and all those things. So how does the floggy works? I don't have to explain it to you. It's pretty straightforward. Let's go to the floggy. Floggy will come in. The automatic FC IDs will be exchanged in there. I'm talking NVMe now, right? NVMe Fibre Channel here. And then there's a B2B will be initialized. It's the same thing with the standard SCSI FCP also, right? Then the ploggy will happen. Here the difference will happen. When the port logs in, it says, hey, I'm an NVMe FC port. And that's where it's going to say my port ID type is 28. And by the way, behind this port, I have a discovery controller also. So now that port over there, port ID, it's a discovery controller. Host is going to say, great, let me go talk to the discovery controller. He's going to send in a command, PR login, process login to the discovery controller in there. The discovery controller is going to say, okay, here are my parameters. I can support sequence level error recovery, whatever my NVMe features I can support. Why don't I create an association? So the host is going to create an association to that discovery controller, which does not have any IOs on it. And it's going to create an admin queue only because there's no I/O queues on the discovery controller. And it's going to ask controllers have IDs, NVMe controllers. They could be dynamically defined or it can be statically. If it's dynamic, it loses its references once you ask for another ID. But if it's static, it will give you the same association again and all that. So now the connection ID is created. Remember, that's where the queuing will be created. NVMe connect command will go in. That will create the I/O queue, admin queue in there. QID 0 in there. There'll be keep alive timers. Just like a TCP has a keep alive timer, NVMe has a keep alive timer at the NVMe level, only on the admin queue, not on the IO queues, okay? All right, so then it will say, okay, I created the IO queue, I'll send you a good status back in there. The status comes back, it says, here's my controller ID, I'm all happy, I have this IO queue established. Then the host will say, tell me your properties, Mr. Controller, what do you have? And the controller will say, okay, I'll tell you all my properties. It could be, the PCI version number. There's a whole list of, go to the spec. That's what I said, download the spec, 2.0. You'll see. Then it will say, is the controller unable? It'll say, yes, the controller is unable. It will say, make it ready to accept the commands now. So all these happens to the commands, property exchange, tunable properties, right? It'll set properties, this and that. The first command it's going to type it in is a get log page. Log page 70 is a specific one which will tell you all the IO controllers attached to this discovery controller or this discovery controller knows about. So the discovery controller will reply back the log page. It will give the subsystem ID of that IO controller 8 with the transport. Here it can tell you the multipathing also. It can tell you you can reach this I/O controller through 3 different ways. So it's automatically, you can load balance at the host side, right? You have this, how to get there. And the association, again, the same thing. You'll get tired of seeing this. Association is created to the I/O controller now. I/O controller, I will create admin property. First, I'll get some property. I'll make the I/O controller ready in there. The same thing like I did with the discovery controller. I'm setting up, enabling it. I'm making the controller ready. This is all properties set and exchange going on, multiple packets going on. And then now I'm going to create an NVMe connection ID. And once I create NVMe connection ID, 0 for the admin queue, 1 for the IO queue 1, 2 for the IO queue 2, up to 65,000 I can go. It depends upon how many number of cores you have, how many you create the IO. Now I'm going to issue an identify command, the host. And that's where I'm going to find out where the namespace, the volume is. And once I get that, I connect to it. Remember, all these things are happening automatically based on the zoning of the fiber channel if you're allowed to do it, and the LUN mapping at the host, at the target, which volumes can be mapped to which namespace, the host port numbers and all that. It's all happened automatically. So that's why when you plug a host into fiber channel NVMe or fiber channel SCSI, everything automatically happens. You don't have to worry about it given the zoning is all done properly. That's why it's very plug and play protocol. And fiber channel storage admin never have to sit with the tracer out there trying to figure it out what protocol is going down or even all those things that I'm talking over here. Let's look at the TCP now. Let's look at TCP architecture. Okay, there's my storage. As I said, NVMe is pretty much identical, it's just the adapter is different. There's a NIC adapter rather than fiber channel adapter. Inside is the same thing, same NVMe, memory space is the same, and the whole thing is the same. Now adapter is over here, is a TCP adapter, right? Now there's NVMe TCP OF loaded in there. I created connection IDs in fiber channel. In TCP, there's not a connection ID, it's a TCP session. We all familiar with TCP sessions. Okay, it goes and creates a TCP session, and I'm going to show you all that in details just to compare you all 3 transports. The fiber channel uses fiber channel exchanges, which is a standard fiber channel protocol, FCP protocol. TCP uses TCP sessions. Every queue is mapped into different TCP session. Every queue is mapped in fiber channel to different exchange ID. Every queue is mapped to different QP pair in InfiniBand. So NVMe SQ CQ is mapped to the InfiniBand send receive queue, right? Just like that. And I won't talk about InfiniBand in here. There are different protocols in there. 8009 TCP protocol is for the discovery. 4420 is for NVMe OF in there. Now, there are 11 PDU types. There were 9 right now, KD requests and all that. 11 PDU type. That means when the TCP packet goes, you look into the TCP payload, the very first byte will tell you what kind of a packet it is. And you have to know all of the 11 very much. First one is called initiate connection request. Let me give you an example of this thing. Here's the packet. You see the very first byte where the blue starts. It's the opcode 00. And here's the initiate connection request going on. One of the things I've done in this presentation is please download, as I said, a lot of traces are there, actual live traces. So you can take it home and you can, when you're testing NVMe TCP, you don't have to stage all that. You can just go through the presentation and you will be like 6 months of testing done by just reading the presentation or perhaps calling me also, Now response comes back. Here's some spec over there on the response. Here's the response looks like. I have the sniffer Wireshark traces. Thanks to Dell for giving me, Eric Smith to giving me Wireshark because it can decode CDC also for me. The standard one on the internet cannot do that. So I have a one which can decode CDC. It saved me a lot of time. There's a kickstart discovery. I'll go into that detail. It's a 0 able over there. This is how the packet looks like in the kickstart discovery. There's another packet called response to that. And then there's a response. And now here's the clever thing. All the NVMe commands are encapsulated inside a command capsule. Command capsule is a fixed size. It started to make me think, maybe ATM days, there was a fixed cells, you move into the switching, it can go faster. Maybe that's why I did 64 bytes. I don't know. I never asked NVMe guys, maybe I'll ask them afterwards. The fixed byte, does it help to switch faster through the switches in there? Obviously it does probably. Then there's a command capsule. You look inside that. So 04 is the very first TCP byte. After that, you count like your, there's a common header, 9 bytes of that starting from 0 if you count that. Then the SQE header starts, 64 bytes. And SQ header looks like this. And this is where all your NVMe command is. This is the holy grail of the whole NVMe in one slide. All the NVMe command. There's admin command separate, IOQ command separate. Admin command goes over the admin queues, IO command goes over the IO queues. There's a fabric commands also. It's a subset of the admin commands. And then there's a new command which added for CDC, I added shown down in the bottom there also. All right, here's an example of an identify going in there. You can see the opcode is 4, and then when you look at the SQ header starting it in there, the opcode is 06. That's an identify command. That's how you figured that out. Don't worry about it. You don't have to troubleshoot it. But every time you're going to go to the customer and say NVMe TCP, the network administrator wants to put a Wireshark on it and figure it out what's going on it, Storage guys never do that, but network guys will do that. So this will come really handy for you. And then the command capsule response will come back. Simply, it'll tell you the status of it. And then, now there is something called fabric commands also. And I started to think why the hell they needed a fabric command within the SQE command and all that. So then I said, okay, NVMe works on, this is my own thinking, I could be wrong. NVMe works with the commands have to go on the queue. Admin queue is not created yet. How the hell I'm going to issue a command on it, right? So that's, so they're setting up the fabric connection, so trying to get to the properties of the other side. They're issuing a connect command. Connect command is the one which is going to create the queue. But the queue is not created, so how do I issue a command on it, right? So that's where the fabric commands comes in. It works out pretty well, actually, And authentication, the whole thing is in there. I'm not going to go into authentication. Please attend Claudio's presentation. He'll be talking about, authentication here. All right, there's a fabric command responses comes back. And then there's NVMe, very straightforward. They say there's a host, there's a controller. Data is going from host to controller, very simple. That's what the packet looks like. And if it's returned, controller to host, this is what the packet looks like. Usually the commands are going from host to controller, response is coming from the controller to the host, right? And then there's a ready to transfer, just the same command in there. And then once you terminate the sessions, host to controller or controller to host terminator comes in. All right, here's MDNS queries, which is now added for the figuring out the CDC, and I'll go through this commands later on, but I'm just giving you a reference packet reference here so you can see how the MDNS query looks like. This is the SD formats which Frank was talking about it, SRVs and all those things. And TCP sync also here, because every queue is mapped into a TCP session over there. All right, you guys ready for CDC now? So this is how it works manually without CDC. If you attach a host on NVMe TCP, there's NVMe storage. How do you find that particular NVMe storage? I'm just checking the time in there. Okay, I need to faster it up. So first is you have to know the address of the storage. The storage will create physical connection to that particular endpoints, and then it will issue a connect command. It will create the queues on that. Response will come back. It will give some dynamic controller ID. Queue association goes on. Properties will be exchanged on that, because now I'm trying to find out about that discovery controller, which is on the storage itself. You don't need a CDC to actually figure it out NVMe TCP. It runs on the storage also. But you need to know the storage IP address on there, right? And the controller properties come back. You set all the queues and everything in there. The properties will come out, and then the properties, it will giving you whatever the status is right now. And now it's going to identify the controller. Again, it's all identifying the discovery controller. Now once there's multiple pages, you can see so much information comes out of that. Identify CNS0, actually, that was executed. Get log page. Now I'm going to get to know which is the IO controller IP address, IO subsystem address, NQN. This is what GB0041, you can't read it, but that's what he says. That IO controller subsystem is this. So host needs to set up the command to that. So host now with the manual entry got the subsystem name of IO controller. Admin has to enter now NVMe connect with that IO subsystem and connect to that. And now what that works is, again, the same thing. Now it's going to go to the target over there. It's going to look for the IO controller subsystem. It's going to do the same thing again. I'm not going to go through all this command. It's going to do the similar thing. It's going to create a NVMe association now to the IO controller so that it can start to do NVMe commands on it. Again, you will have all these slides in there. It's get to know the properties in there, what kind of NVMe command sets I'm doing, what kind of an arbitration method. I get the status, my controller status. Okay, I'm ready to do that. I am get fine. I get controller IDs, version numbers of this, and so forth. Tons of information gets exchanged. Now I want to know what the namespace is behind this IO, because I want to talk to the IO. And now the identify. Remember, same commands, right? Fiber channel, same command, NVMe. That's where the beauty of NVMe protocol is. You don't have to worry about different command sets in there. Here is one thing I figured it out during the testing. Different hosts were asking different number of the queues. I said, what happened in here, my host UCS server has 64 core. It's asking for 64 IO queues. The controller over there has 8 cores. It says I can only do 8 IO queues. So NVMe will let you adjust that. And the way the NVMe driver figures it out, I don't have time to go into the block MQ in case of a Linux. There's a software staging which takes care of the cores, and then there's a hardware staging which takes care of the NVMe side, driver side, and then they map all the right number of the queues. So, it negotiates it down to the 8 queues, and now there'll be 8 IO queues will be established in there. So in the connect request will go 8 times, and I'm not going to show you all of them, but 8 IO queues on NVMe TCP will start it with 8 different TCP sessions in there. 8 TCP session goes in there, and now what is going to happen is 5 more minutes left. And now in fiber channel, there's a concept RSCN, right? State change notification. There is a concept there also, AER, asynchronous event, registration. What it does is the host will register an AER request with the target, and anytime a target has any new changed information, it will take that request and respond to it. So that means target can hold on to that AER request forever, whatever he wants. But once it reply back, then the host will register another AER on there, right? And you can see in these packets all these requests going on in there. So the minute it holds a request, there's no timeout value to AER. I took a lot of time to decipher all this spec and the traces and to try to match it. The biggest thing threw me off was little endian and big endian, I got so confused, my packets were not matching with the spec. But I figured that out also, I mean, guys who are laughing know what I'm talking about here, Okay, the active namespace came back. Now I know the namespace ID is ID01. All I'm going to do is I'm going to send ID namespace 01, give me your details. And ID namespace is going to say, this is my namespace 0, this is my capacity, this is LBA format looks like, this is blah, blah, blah. Now I can say, read that LBA, I'm going to issue the command read, I'm going to send out LBA starting address, number of logical blocks, all read in there. Let me quickly walk you through how with CDC it works out, right? Because I have like 5 more minutes left in there. So this is a manual process without CDC, 2 steps. 1 host, it works out good, a dozen hosts, it works out good. You got 1,000 hosts, dozens of storage. This is a nightmare, and things changes. So this admin guy, poor guy, the minute it issues a connect, discover command, things can change, so it's not going to work out. Right? So NVMe guy said, okay, what we need to do is come out with some standard, solve this problem. So they said, why doesn't the host, when it comes up, 10 minutes, why doesn't the host, when it comes up, sends and registers it information, I'm the host, I'm looking for NVMe target, please. Okay, great. That's called push registration. But in NVMe world, in storage world, storage is a target. Storage doesn't go around and tell the host that I am the storage. Host has to come to the storage to ask for storage, right? Discovery controllers are at the host, at the storage. So how does a storage tell a host that you need to talk to me? Okay, so there is a concept here called pull. So this centralized discovery controller VM, the host will register its information to the centralized VM that I'm the host. I want the NVMe connection to the storage. The storage will come and tell the centralized discovery controller, please pull the information out of me. I'm a storage. I'm a target. I can't act like a host. I can't push the information to you. So please pull the information. So that's where the interesting things happen. Then somebody asked, there is a zoning command, we call it a CDC Fabric zoning, done at the CDC level. You have to say that this host can talk to this subsystem. So NQNs, both of them put it in the same zone members in there. Then when that host comes in there, this CDC will tell him that yes, there is a subsystem for you. But still don't guarantee that you will get the volume. You can access to the subsystem. You have to do the LUN mapping, the volume mapping at the storage. That's still, so 2 manual steps in here, which you do it in the fiber channel also, is the zoning at the CDC and at the LUN mapping at the storage, right? It took me a little while to figure it out, but it all works great. You can do it in any order, it doesn't matter, CDC will figure it out. Look at it in here. So what is inside the host? And I think again, Claudio is talking about this NVMe stash presentation. Please watch that. I just copied his GitHub diagram in there. So the host has to come out, look for the centralized discovery controller. It has to be 0 config. So MDNS is the protocol to do that. You can look at that. This is how the packet looks like in there. CDC controller has 3 things in there. Database is a host database, a subsystem database, a direct discovery database. And then it also has is a zoning. That means which host can talk to which subsystem in there, that information in there. All right. You already know how the subsystem works in there, right? Same thing with TCP. My goal with CDC is the Linux host will come out with this NVMe stash. NVMe stash has all these drivers. CDC is running in the network, and then my TCP storage is there. Let's see how it all works out. I have 5 minutes left. CDC comes up, it's going to start blasting NVMe, TCP, DNS, and MDNS commands automatically. And then the host, as it sends the commands out, once it finds out there's a CDC, it will send out its push the service records over there. And all these records are there, right? And then it will continue to announce that, hey, on this host, I know this CDC out is there, so that everybody's on the same page. Okay, great. Now remember, the controller is acting like a controller. In a minute, the controller will act like a host also. That's the beauty of CDC. 5 minutes left. Thank you very much. Okay, same thing. It's an NVMe connection. Initiate connection goes on to the CDC now, not to the host or discovery target yet, because he doesn't know about discovery target yet. Okay, the same NVMe connect response to the CDC. You already know this thing. I've shown you the NVMe TCP packets in details in there. Controller comes up. I'm creating an NVMe. I'm trying to create an NVMe connection to the CDC. At this time, I'm going to say identify who you are to the CDC controller. And now I'm going to start setting I'm setting up here the AER request and all that. That's fine. Now, here is the key part. Here is the new command. Now the host at this point is going to push its information, DIM, database information management, right? It's all information to the CDC. Okay, CDC gets that information, it will put it into database. I discovered a host, its NQN name is this. I'm going to rush it up over here. So now in the CDC database, there's a discovery host in there. Okay, now, and the TCP keep alive is gone, and there are 2 keep alives going on, TCP level and NVMe level, right? So NVMe is usually higher, 30 seconds, TCP is 15 seconds or something, or yeah, that's the right way to do that, right? Okay, now the discovery control, the target, when I power the power store, in this case, this is Dell's power store, when I power that on, I put an analyzer on it, it is also doing some kind of a MDNS query on it. It is saying, hey, I'm looking for CDC. That's an MDNS query, right? And the CDC will respond, says, hey, I'm the CDC for you also. Just like it responded for the host. Okay, here's the problem. The host was able to send a DIM command and push its information. Storage cannot do that. Storage is not a host, storage is a target. Storage has to tell the CDC to push the information. CDC is a target also because host was talking to the target. But CDC will change its mode and it will become a host and it will talk to this target. And how it works is they set a flag in the initiate connection request, says, I'm going to issue a kickstart discovery request. That means, I don't know who came up with the kickstart. So you're kicking the CDC here, fetch information out of me, that's you're kicking it. And CDC will say, oh, sure, I can do that. I have this thing. So it will end that particular session. It will start another session to pull the information out. All it's looking for is a discovery log page so it can find out what IO controllers are there. So same thing will happen, discovery, connect and all that. Now you will find out in the CDC database, there is the DDC information also, right? That discovery target. Okay, now I know in CDC there's a discovery host, there's a DDC, there's a subsystem IO. Now I need to do some kind of a zoning in their host so that which host can talk to which subsystem. And then I have to go to the target and map that LUN. Okay, last 2 minutes. Very simple. Now, again, I'll just quickly go through this thing. Now I'm going to go look for the log page. The host comes out. Now it's looking for the discovery controller. Now since the CDC, the fabric zoning is there, when it replies back to the log page, it will give him the discovery controller address. the sub NQN name. The host will go ahead and create an NVMe session, admin queue session only to the discovery controller, and it will find out the identifier, it will find out all the features, and actually it will find out the log page in there, and it will issue a namespace and all those things. Now, this mapping is already done at the target, and now what is going to happen is that the host is talking to the target and asking for it, the namespace list, and what is the active namespace list, and the IO controller at the target will give him the active namespace list. That's the namespace ID. It says I have a namespace ID 009, and now it is going to go ahead and map that volume. So at the host, what you will see now, he can do the read commands. So at the host now, with this automatic, now I'm ending the last minute here, 60 seconds. Now with this CDC, we are able to provide discovery services, just like in Fiber Channel. We are able to do endpoint registration, whether it's the host or the target. We are able to do zoning kind of a features in there. We are able to do RSCN kind of a features like asynchronous notification. My goodness, this is like starts to look like Fiber Channel to me on the Ethernet side, you know, and that's great, and it's Ethernet. So back to the thing, and I have a whole appendix in there. You can go through that. I have some other presentations on the YouTube. Please go through that and do rate your this session, because that's how they're gonna make me come back here again. If you really want me, please want me. Thank you. Any questions, you know? And by the way, there's a tons of information. I can go through the whole evolution. I won't go it, but you take your presentations and you can go through that, you know. Any questions? Anybody? You must have it. So my bottom line is keep your Fiber Channel network. Cisco is going to take you to 128 gig. Divide your workload into different policies. This is my mission critical application. Running on Fiber Channel, keep running on Fiber Channel. Don't change that until all these Fabric services and everything. But start a pilot on NVMe TCP, please do. Because it took me 2 years to get to this point. It'll take you 2 years to get to that point. And in 2 years, NVMe TCP will come out with more enhancements, security and all that. It'll be more closer matching to Fiber Channel. And if you start at that time, you will be left behind in the competitive game. So test NVMe TCP, even if it's a small test. Put some application analytics or something. Yeah, please. Okay, very good question. Which is cheaper? Now, you cannot compare apple to apple in there, right? So HBA, if you look at the Fiber Channel, today is 32 gigs, 64 gigs is out. By the time you add optics cost in there, you go buy an Intel or Mellanox 100 gig Ethernet card. Of course, 100 gig Ethernet card with optics is cheaper, almost half the cost of the Fiber Channel 64 gig optics, you know, from anybody, right? From Emulex or from anybody. Now, price was never the issue. A storage customer, storage admin, what is the biggest thing they do? What is PowerStore doing? They make PowerMax doing, or HP. They make everything redundant. 2 power supplies, 2 this thing, making snapshots. So availability of the data, highly available of the storage. Money is not a matter to storage guys at this point. They want the storage should not be lost. If they write a file, that file should be there regardless of whatever happens. There's all sorts of disaster recovery protocols, this and that, SRDFs, and everything goes on in there. So if you come out with the EBOF, and I'm not against EBOF, I'm testing Marvel's EBOF also works great. But where are the storage services? If something goes wrong in it, what do you do about it? So this intelligence, which that matters. So the price to the intelligence is what you buy with storage, with Fiber Channel. With Ethernet, we're still coming out with that intelligence. CDC is the first step towards it. Snapshots is happening. Dispersed namespace might help you that. You can disaster recovery that out. So in the long run, as I said, one of the analysts said, where does the cloud storage go? That's where the customer is going to go. So it's up to you. Today, cloud storage runs Rocky, most of them. TCP also. Google runs its own protocol, Quick protocol. Amazon runs SRD or something, different kind of a. So, but I believe that it is going to end up as TCP, but Fiber Channel is not going to die because there's a billions of dollars investment in Fiber Channel and all the financial applications. It's a dedicated network. I haven't seen any hacker hack into Fiber Channel. I mean, the storage admin themselves cannot hack into their own network. How can outside guy can hack into the Fiber Channel? TCP, a kid can hack into a TCP network, you know, DDoS attacks on the TCP. So that's where Claudio's job is to make TCP network more secure. Any other questions? All right, guys, thank you very much.